quickly so people can see it. First of all, first point, notice learning outcomes. What's the first line? It says learning outcomes, then it says
By the end of the unit.
by the end of the unit. You're not trying to achieve these things as you go along at any particular time, it's by the end of the unit. Right, so when you're planning, like just on a lesson by lesson basis over a few weeks like we are, even though those are the big picture things about what we're trying to do, it's the descriptions that we're going for. So, by the time we finish this, we want to determine the coordinates of the midpoint of 2 points. Direct proportion linearly related variables. What does that mean? Examine examples of direct proportion and linear related variables. Why are they putting linearly related variables and direct proportion in the same statement? Because they're the same thing.
So reinforce the idea.
Yes. Direct. You remember when you did proportion, they do it in about grade 9 or 10. You know, you double this, you double that. They're in direct proportion. That's a linear relationship. If I triple this, I triple that. So direct proportion is the lower secondary school way of explaining, of talking about linear relationships. Next. Recognise features of the graph y equals mx plus c, including its linear nature, its intercept, its slope or gradient. So that's 3. Let's see how many there are altogether. Equation of a straight line, parallel and perpendicular lines, solve linear equations, quadratics, equation of quadratic, turning points, inverse proportion, powers and polynomials, coefficients in degree of a polynomial, prime states, graphs of relations, and that's just the function, the linear and linear relationships bit. If you just start at the beginning and go point by point by point, how long is that bit going to take?
A while.
A while?
It also doesn't reinforce because it's repeated in the graphs section.
Yes. Let's have a look a bit further down. Features of graphs, but that's a circle, x squared plus y squared equals r squared. And does it talk about it up there at all? Nope. Okay, so we've got a circle. Now we go to functions. We've got 1, 2, 3, 4, 5, and that's it. Then we go to topic 2. So there are about a dozen of them, maybe a few more. How much of that will you get through in 3 weeks?
Maybe a section?
Maybe a section, who knows. What I would suggest is, as we've talked about in the past, trying to, when you've done these first 3 activities, you know what we were talking about a minute ago about the oval and all that sort of stuff? What I would try to do is to take those examples that we've used and then use that as the basis for this stuff. How can you go from having them talk about things like you've got a Cartesian plane that uniquely identified a point. How do you extend that now into the idea of a straight line?
2 points?
2 points. Or
A line?
2 points doesn't make a line. How many points makes a line?
Everything in between.
An infinite number of points. How can I model that with the students? Remember, they've already been out on the oval, they've already talked about axes, they already know how to uniquely identify 1 point. How can I now extend that to this?
Get them to use their origin and then move themselves to the point of the oval?
Yes, and then keep going. How can I make a line out of my students? I would do is this. I'd go out on the quadrangle, like that, and I would go, I'd pick a nice easy one for a start, y equals x. Alright, I'd get the first person to go out 1, 1. Next person to go out
Would be 2, 2.
2, 2. Next person, I wouldn't tell them that we're drawing a line. I'd just say, all right, you go out to 1, 1. You go out to 2, 2. You go out to 3, 3. You go out to 4, 4. What will they notice happening?
They're lining up.
They're lining up. And then go, okay, we're now lining up. What was the relationship when you went out there with the coordinates? What was the relationship between the coordinates that I gave you? They'd all go, oh, they're always the same. Good. So rather than talk about 1, 1 and 2, 2, if we're talking about anywhere on this line, we talk about y equals x. And then generate an equation for that. If I go, I tell one to go out 1, 3. I tell the next one to go out
1,
2,
6.
6.
Let's try and
The next
work out
one
which
would
one.
go
is-
3, 9. And as you do more and more, again, you would generate a straight line. And then they would notice, then you go, okay, we've just done this. What's the real connection between our coordinate values this time? And they go, that one is always
3 times that.
3 times that one. We represent that with that. That one, the y one, is always 3 times the other one. And so on. So the point is, you started with a certain context in the engagement phase, and now you're starting, it gives you a tool to use to explain what you're going to do later on as well. So that's how I can get into equations of lines. How can I get into the midpoint of a line doing this? I'm out on the paddock. There's one, there's another. I put a person there at some easy place like 1, 1. I put another person there at some other coordinate, and then I get 3 other people to go, okay, I want you to go and stand at the point between them and tell me what your coordinates are. That sort of thing. Now, will you use all these practical activities necessarily? No, they're just things that you can, they're potentially sitting there that you can use. These sorts of things are things that I use. If you try and teach something, 10 kids haven't got a clue what's going on. That's what this is for. Kids who are in year 11, they're just getting to the point where they can abstract information. And some of them don't need this, but some of them do. So what you need to do and have up your sleeve regularly are these sorts of concrete examples to illustrate the point. That makes sense too? So all of this body in here is going to be the mathematics you're actually, the new content that you're working on that's building out of the context that you've done in the Engage. It's better not to go to something different if you can avoid it. Because if it's a different context, they have to re-engage their mind with the new context as well as the mathematics. Right. Once you've gone through a process where you've now got your whole 12 lessons, you've decided the sort of thing you can do there, the big activity at the end that you wanted, where they really want to apply what they know, you've got some evaluation, you can then just fit in here whatever you think you might want to use to get through the work you're going to get through.
So that last bit, is that where the reflection, that's reflection also?
Yes.
Okay.
Yeah, it's about everybody sitting down and going, well, this is what we've been trying to do. How'd we go? Where are we still? What things do we know well? What don't you know? Now, once you've done all this, notice that what we've done up to this point, we haven't put pen to paper yet to actually write up the lesson sequence. This is the sort of thing you should do. That is, give it time, think about it, ponder how you might do it, get an